Moving on to the next question, which is asked in test series 3 for IN stream, is from the subject process control, and it is for 2 marks, basically fill in the blanks type, and it is from the topic process control system configurations. So here we will analyze the question. So here we are given with a transfer function of a plant or a process whose transfer function is gp of s equal to 1 by s plus 1 into 3s plus 4, and here a negative feedback is employed. So here we are not given with any, here it is only said that it is a negative feedback, so it means the feedback value is 1, and here the measurement device is transfer function is gm of s equal to 1 by 4s plus 1. So this is a device which is measuring the output and is feeding back the output to the input. So here we have gm of s, which is effectively the feedback system whose transfer function is given, y is 1 by 4s plus 1, and here we also have a controller which is of type proportional. So you can see here a proportional controller is used. So what is the frequency of oscillation at its ultimate gain or the maximum gain? So here we are asked to find what is the frequency of oscillation when we operate the overall system at the maximum gain which is allowed to. As we know from control system that when the gain is maximum, we see the system starting oscillating where in a sine wave whose frequency is being asked. So here when I draw it in terms of a closed loop system with the feedback, the overall question can be converted into a diagram like this as shown below. So here you can see a gain is there whose value is proportional controller of gain kp, and the transfer function of the plant is embedded here, which is 1 by s plus 1 into 3s plus 4, and we have a negative feedback whose transfer function is 1 by 4s plus 1, and here you can see it's a negative feedback where input is being subtracted from the output. So we need to calculate what is the maximum gain of the system which it can be allowed to, and when it is operated at this gain, what is the frequency of oscillation of the overall system. So there are 2 questions which are asked. So first question is to calculate the gain, max gain here. So here for all these kind of problems where we are asked to compute the gain or the frequency of oscillation, first we need to calculate the characteristic equation of the system. So here that is what I am doing it here, which is given as 1 plus GSHS. So here we know the forward path transfer function is kp into 1 by s plus 1 into 3s plus 4, which is gs, and we know hs is 1 by 4s plus 1. So when I multiply both of them, I get the characteristic equation as 1 plus kp by s plus 1 into 3s plus 4 into 4s plus 1. So you can clearly see I have multiplied both g of s and h of s. So here I can draw it. So this is my h of s, and this overall is my g of s. So I am multiplying the product, which comes out as this, which is 1 plus kp by s plus 1 into 3s plus 4 into 4s plus 1. So when I multiply it and take it to my LHS, I get a cubic equation which is 12x cube plus 31s square plus 23s plus 4 plus kp equal to 0. So now I have to construct a Routh array table, which we have already discussed in control systems. So which is nothing but I get the table in terms of x cube and s square. So when I solve it for oscillation, I need to equate the lowest term to 0, which is with that what I get is, so here you can see my gain range is 55.41, which is the max allowed gain. So from this equation the gain should be greater than 0, and it should, from this equation what I get is it should be less than 55.41. So the maximum allowed gain for this given system is 55.41, which we have calculated as first step, and we need to calculate what is the oscillation when we give this kind of gain to the system, which you can calculate from SS. So which is I'm equating this equation 31s square plus 4 plus kp equal to 0. So when I substitute the kp value as 55.41 and solve for omega, which is nothing but s equal to j omega, I get omega as 1.38 radians per second. So my oscillation frequency omega will be, when I operate the system at the ultimate gain, which is 55.41, is 1.38 radians per second. So hence we understand that we should never operate the system at the ultimate gain, because the system starts oscillating and it will be uncontrollable.